Okay, so hello guys. So we are going to have an introduction to the physics for engineers subject. So if we run through sa aton nga modules, so or sa na-upload naton nga materials dara sa aton nga Google Classroom. So we have almost 14 siguro ka modules yung kinahanglan naton ma-discuss all throughout the discussion naton sa physics for engineers. So we have to inspect for example sa aton nga kinahanglan i-discuss nga topics. We have the following. We are going to, for the first module, we have the units and statistics. We are go or statics, I mean. We have to understand and go back on the concept of ano nga mga units yung ginagamit natin for science. At the same time, we will be having a lot of problems. Balikan nyo ang mga concept of measurement. At the same time, statics and the concept of vectors. So, kinanglan natin balikan. We have also to discuss the properties of matters. So, we have to consider elasticity, viscosity, surface tension, yung mga properties of matters. Also, part of this discussion, syempre, which is very relevant to the study of civil engineering will be the concept of dynamics. So we have to understand straight line motion, projectile motion, circular motions, yung tinangan natin mas maintindihan. Also, part of the more complex or na form of dynamics will be the rotational motion of rigid bodies, gravitation, satellites. So, medyo, if we have sa last part sa ating nga discussion, we will have medyo ng simple, medyo hindi amo na ka-complex nga topics like sound and magnetism. We will also have electricity nga topics, hindi mga natin mas maintindihan. And we'll have the concept of heat, thermodynamics, liquefaction, gases, and unconventional energy. We will also have to understand the concept of optics later on. And I don't know if we need also to discuss the concept of electronics because specifically the concept of electronics or physics will be discussed in the field of electronics engineering students. But I don't know if pwede pa siya natin habol later on. But we have to understand the basics of physics. So if we run through sa aton nga first na discussion, we have to understand the concept of SI units and statics. So based diri sa aton nga discussion or sa aton nga module, we have to understand kung ano ang physics. So the word physics comes from the Greek word nga ang butsilingon is nature. Today, physics is treated as the most fundamental branch of science and finds numerous applications of life. So physics deals with matter in relation to energy and accurate measurement of the same. Thus, physics is inherently a science of measurement. The fundamental of physics form the basis for the study and development of engineering and technology. Measurement consists of the comparison of an unknown quantity with a known fixed quantity. The quantity uses the standard of measurement is called unit. For example, we have a vegetable vendor weighs the vegetable in terms of units like kilogram. So, amo nang concept nato ang kailangan mabalaan or maintindihan in the first part sa aton nga discussion for physics. But we have to, this is an introduction sa aton nga study of physics, we have to first relate this kung nga atin ang lang naton mag-study sa physics, especially in the field of engineering. So, nga atin ang lang naton mag-study physics. So, if you are interested in building your career in engineering, then studying physics is obvious. We can't imagine our life without physics. So, the future technology directly or indirectly is related to physicists who have made a huge contribution to the world. So, if we are going to inspect kung anong kakatabo sa kalibutan or ano ang mga changes nga ari diri sa kalibutan or even the technologies nga na-develop. So that is governed by the laws of physics. So we have to understand that later on as we progress sa ating discussion sa mga topics natin sa physics. So engineering is a profession in which a scientific knowledge and mathematics is used for the innovation to develop new things that benefit mankind, which is important to society and nature, making everything around us easier. So engineering is the mindset to think over the use of scientific principles to design and build machines, structures, and other items. Engineering enables us to think out of the box. So hambagan ninyo ilawag hambak ako ng engineering, you are into solving sa mga problems natin. So problems nga ka-experience and then kung ano man ang problem ang ma-discover sang either scientist or mga iba nga field nga nag-study. So amo na din ang pangitaan sang solusyon sa mga engineers. Ang bagal nila kuno kung wala kuno sa makita ang problema ang mga engineers, sobrang sila kagaling ng mga problema. And then they have to solve it. So, basic sciences have their own importance in the broad spectrum of engineering. So, knowledge of science helps the engineer understand the constraints inherent in a problem, and it helps the engineer. So, it helps the engineer develop possible approaches for a solution. Now, let's throw some light on the role of physics sa engineering. So, this is not only ang aring study. This is not only focused on the help sa engineering sa field ninyo as civil engineers. But this one is tanan-tanan yung field of engineering ano ihan ang bulig sa physics sa iya. So this study will be focusing on sinang aspect. Physics is one of the most fundamental scientific na discipline, and its main goal is to understand how the universe behaves. So, physics generates fundamental knowledge needed para sa ating mga future technological advances. The study of physics develops the ability of problem solving, logical thinking, and also the ability to think intellectually. So, bisan sa inyong mga senior high school nga study, if we have to consider kung ano ang physics, so syempre kinanglan natin problem solving skills, dari logical thinking skills, at the same time syempre ang inyong knowledge sa mathematics. So, physical concepts such as classical nga mechanics, so amo nga mga branch ang related into the physics kinahanglan naton maintindihan. We have thermodynamics, statistical mechanics, so we have electromagnetism, part man siya sa physics. We have quantum mechanics, we have also atomic physics, molecular physics. So syempre sanhamba ko na we have optics. So if we talk about optics, we are talking here about light. Also, we have condensed matter physics, nuclear physics. So this all branches of physics plays a vital role in the process of innovation, which is crucial sa development sa mga engineering branches. So kung tanawon nimo ang mga sari-sari nga mga fields of physics gintong mention naton, they have a great contribution sa sari-sari nga field or sari-sari nga types of engineering courses. So engineering is basically physics applied to create something more practical. So it can be mechanical, pwede man electrical, pwede electronics, pwede civil, but they're all basically governed by physics. So tanan-tanan gid na nga field of engineering may ara gid physics nga application. That's why if we are going to inspect sa inyong mga curriculum or sa inyong mga subjects nga kwaon later on, especially for civil engineers, medyo importante gid ang study of physics. That's why ang physics mismo is a prerequisite sa tanan-tanan halos ng mga major subjects for civil engineers because importante ang concept, especially in the field of vectors, forces, dynamics. So, medyo kinanglanon gid ang concept of physics. So, in civil engineering, for example, the laws of physics can tell you about forces, tensions, so harmonic vibrations and oscillations, tensile strength, elasticity, and all kinds of other concepts. So, tanan-tanan yung dimension natin, um, they can be used to make calculations about your designs in the future. Kung syempre sa mga construction work na himuon. So, importante na katama. For every subject naman, for example, if we talk about mechanical engineering, so kinanglan man nila Japan sa physics. So, they are going to use the concepts of physics in dealing with. So, syempre, mga mechanical engineers, they work with aircraft, mga watercraft, engines, robotics, weapons, cars. So, tanan ni, they are governed by the laws of physics. So, electronics naman niya sa especially sa amon, electronics and electrical engineering. So this involves designing electrical circuits. So including some motors na siya po, may mga motors man, mga electronic appliances, mga generators, so optical ng mga fiber networks, so computers, communication links. So electronics, mga for example, electrical engineers man, they need to convert electrical energy to other forms of energy. So with the understanding of mechanics and thermodynamics, knowing the fundamental of this field of engineering, in addition to how small-scale components like mga IC ang natawag natin or the integrated circuits or bisan ano pa na nga mga electronic components like transistors, resistors, all functions requires at least an intermediate understanding of electromagnetism which you learn from physics. Electronics include the workings ng mga transistors, diodes, semiconductors, ICs, which uses physics to study kung paano ni sila tanan interconnected in a circuit. Electromagnetism is used for mga antenna nga design, RF signals, or radio frequency signals, mga wireless communications, etc. So, the field of robotics man relies on a lot of things physics such as dynamics, chaos, mechanics, motors, etc. So as well as mga optics ni nga ginagamit natin for camera or computer ng mga vision. So means electrical and engineering leads to electronics engineering and finally to computer engineering and information technology or pwede man sa mga more advanced na ganito artificial intelligence, it can be concluded that the mother of all engineering branches is physics. An engineer might design the product itself or just figure out a way to build it. But either way, success is impossible without understanding the concept of physics behind each of them. This is true that has a great and significant role in the field of engineering. So, despite the fact that you have may mga majoring ka that focuses on the specific ng mga topics na gintong mention natin, but still, the ang bisan may majoring ka pa in the future nga kwaon, still the concept or the basic concept of physics applies to it all. So kinahanglan naton mas maintindihan syempre ang basic of physics para mas maintindihan naton later on ang mga complex or the advanced topics or subjects related sa aton ng mga specific field or courses. Okay, so we have to understand sang study naton of the concept of physics, but we have to subong kinahanglan lang naton i-run through ano ni ang mga topics na kinahanglan naton studyhan or ano ni ang mga coverage ng physics bisan hindi man ni naton ma-discuss tanan-tanan, but we have to know lang wala kung ano ka wide ang range sa study of physics. So I have here the big picture frontier of modern physics. So this will be covering yung mga topics. You have energy and power. So probably the greatest problem facing humanity in the 21st century is energy. So kabalo kita. Ang halos sa mga advanced ang halos sa mga studies, they focuses on energy and power. So especially that we want to um, make bala sa mga advancements in technology. So kinahanglan we amo nang reason kung may mga study about different types of energy, different types of ways para makaproduce kita sa energy. So energy is indeed a basic physics concept and power is the rate at which energy is converted. Satisfying the need for energy can carry huge risk. So this is one of the topic na kailangan natin discuss later on. We have energy and power. So physics is at the center of large number of interdisciplinary collaboration, seeking ways to secure our energy future. So that's why may ara nga sari-sari ng study of kung paano. paano kita makaproduce energy. So, in the concept sang chemistry, so may ara sila sang sari-sari nga nga types of energy, types of or mga sources of energy kung paano sila kina-generate. So, also, we have another branch of physics which is the quantum physics. The year 2005 marked the 100th anniversary of Einstein's landmark papers. So, maghambak kita quantum physics, this will be focusing on the theory of relativity nga gin-develop ni Einstein. So, we have sa sini nga mga um, discussion, and this um, focuses on the concept of quantum revolution nga naghalin jud sa study ni Einstein. So this one um, give birth man into sa bag-o naman bala nga type of matter or bag-o naman siya nga phase of matter, ginatawag natin BEC or the Bose-Einstein condensate. So, but it's far from the understanding natin or sa aton yung kinamaya discuss sa subong nga field of physics or sa subong natin yung understanding ng physics. But this is important to understand this concept because this governs the rule or the kung paano nagagana ang mga CD, DVD, or sa mga eye surgeries. So, that's governed sang study of quantum physics. Next, condensed matter physics. So the transistor was discovered 50 years ago, bringing in the electronic age. May ara man kita mga CPU sa mga typical laptop computers uses more than 100 million transistors. So Gordon Moore, co-founder of Intel, observed that computer processing power doubles every 2 years. Computer storage grows even faster than processing power, doubling every year. In the year 2007, Nobel Prize was awarded to Furt and Granberg for 1988 discovery of the giant magneto resistance. Network capacity doubles every 9 months. So, ang tanong mo naton, ang focus of your quantum nga or the condensed matter nga physics is on more on the development of electronics kag technology. So we have also quantum computing. So this is in the higher field of physics. So since we are running through lang man sang sininga discussion, we have to um, labyan lang natin ang iba niyang part. So we have computational physics. Traditional physics was either experimental or theoretical. Textbook tends to be theoretical. A lot of research originates experimentally when phenomena are developed to describe theoretically. A third branch has emerged, which is the computational physics. It includes chaos and nonlinear dynamics. It was Edward Lorenz, who is very famous for simulating weather phenomena and discovering that very small differences in the initial condition of simulation resulted in a very large deviation in the final prediction. So, si Edward Lorenz, siya na yung nag-study sa ginatawag natin yung butterfly effect. So, anong butterfly effect? Let me just give you a small background what is a butterfly effect. So, maghambag kita butterfly effect. This focuses on the concept of chaos. So, ano naman yung concept of chaos? So, maghambag kita chaotic effect in the in terms of engineering. Ang ginhamba lang mo sa butterfly effect is so, ang ginhatag na example ni Edward Lorenz is that so this might sound strange or mahamba ka mga ka imposible but ang ginhambal ni Edward Lorenz, hambal niya, ang gamay lang ba ko nga flap of wings of a butterfly could possibly create a huge katama nga hurricane sa ibang part of the world. So, ang munang hambal ni Edward Lorenz. And this was his study, so which was uh, accepted in the field of physics. Nga bisan ng gagmay lang ang mga butang nga kakatabo in the some parts of the world could create an impact sa ibang pang part ng kalibutan. So this is the concept of complexity and chaos nga iyan na um, study, which could be seen in the concept of sunpiles, traffic, so tanan ni halos, they are governed by complexity and chaos. So, another field of physics nga medyo ano na siya subong medyo kilala na siya, which is the nanotechnology. So, kung tanawon naton, nanotechnology is we are trying to zoom in some pictures or some kung anong nagakatabo in the smaller pag lang nga picture, kung tanawon naton, padakuon naton na ang mga kung paano kakatabo. For example, rust, anong kakatabo sa sulod sina, anong paano gina-govern, ano ang science behind sa nagakatabo ng mga gagmay-gagmay ng mga um, phenomenon. Next, we have biophysics. So, a rapid interdisciplinary conversion is taking place between physics and molecular biology. So, this is more of the concept of life ang ginastadihan dari when we talk about biophysics. Next, w- the even the study of physics extends up to the high energy particles. So that's why ang physics is ginagamit for the understanding of nuclear energy. So kung magkabag kita nuclear energy, ang ginastadihan din natin is particles. So high energy ng mga particles. Kung paano siya nagagana. So that's still part of the study of physics. So we have also, part ng study of physics is the astrophysics, which is focusing on the universe, entire universe, kung paano na sila gagana. So we have astrophysics. So bisan ang mga energy na sagwa or ang mga kung paano nagagana na sagwa, still it is governed by physics. Ang muna nga ginastadihan Japan in the field of physics. Okay, so kung matandaan or kung matanaw naton, ang study of physics is from halin sa pinakagamay nga particles up to the uh, dako-dako gid nga wide range hasta sa entire universe. It's still governed by physics. That's why halos ni nga understanding of the concept of physics medyo dako-dako siya katama nga field kung studyhan mo gid ang physics. That's why amo na siya nga ginatunga-tunga siya yan sa sari-sari balang categories or sari-sari nga branches of physics. Kaya para mas mafokusan ang pag-study sa So, subong, we have to understand nga akin ang lano natin sa physics. So, syempre, first gid, it is required para sa mga major ninyo. Prerequisite ang physics. Physics um, is a sa nahambal na naton basics ang tanan ng mga kinanglan naton matunan for sa aton ng mga courses. Physics is a science in which all natural sciences and engineering are built. All modern technology traces back to basic physics. The study of physics will help you grasp scale of distance, mass, time, energy, and others, unifying concept for understanding how we fit in the universe. So physics is based on well-designed experiments and consistent theories. Informed citizens will form the public policies for the future, and this is you. So kung kabalo ka mo kung paano nagagana ang mga specific ng mga butang dari sa kalibutan on the concept of physics laws. So makabalo ka mo kung paano mag-ubra sang policies or kung paano mag-develop sa mga systems in the future. So that will be you. You will help kung paano naton i-develop na ang mga systems in the future. Okay, so if we will be solving some problems in the field of physics or sa subject ng physics, we will really be dealing with big numbers or really small numbers. Since nakita naton bala ang concept halin sa pinakagamay-gamay nga particles hasta sa pinakadako-dako nga particles hasta sa bilog ng universe amo naton nga studyhan. So halin sa pinakagamay that will be included dara ang concept of numbers. So kung sadihan naman sila gagmay-gagmay na nga number, kung asta naman sa ma-extend kita besa sa bilog na universe na, it will be a large number. That's why we have to study or we have to understand the concept of scientific notation. So to deal with big and small numbers, dali na masulod ang concept of scientific notation. So maghambag ito scientific notation, we have composed of sa ginatawag natin nga base or this base ginatawag na siya naton nga okay, so ang ini nga base or ang ini ang base din natin, ginatawag na siya natin nga mantisa. And then we are multiplying that one into times 10 raised to the power of any possible exponent. The mantisa is usually chosen so that it has one digit preceding a decimal point. For example, 3 times 10 raised to the power of something, or 3 times 10 raised to the power of 10, 3 times 10 raised to the power of 8. So, but take note that this does not always happen. The exponent is an integer representing the powers of 10. Multiplication and division are simplified, so using the scientific notation. So medyo mas mapahapon